We have one more speaker who brings a wealth of experience in resource estimation and mine operations. Anthony is a geostatitian with an extensive experience working across both open pit and underground mining. He's worked in a variety of precious metals deposits in diverse geological settings, from alluvial, supergene, oxide to in-situ, hard rock mineralisation. I've got no idea what that means. Is that soil? So soil and rock? Yeah. Previously, Anthony was the product manager for Supervisor, one of Datamine's leading geostats programs, where he uses deep technical expertise to enhance data analysis tools for the industry. Now, as a VP of Geology, he drives a joint strategy for Datamine's geology products with a key focus on enhancing interoperability. Take it away, Anthony.
Thanks, Braden. And I suppose to make some thanks for everyone for coming along today. Thanks for Beck for doing all the organisation. And thanks to Jono for volunteering me to talk. So I hope, as Braden mentioned, I'm a geologist. So just out of curiosity, if you could do me a favour and just very quickly, if you're a geologist, just raise your hand. Okay. And if you're an engineer, raise your hand. Okay, I'll have to be pretty careful about which jokes I leave in then in that case. Maybe not my usual material. But I do want to say that in the mining data stream and the mining space, as part of my role previously as a consultant for Snowden Optiro, I used to do reconciliation reviews and audits. And if you haven't been a part of those before, don't worry, there's still time. But what they generally look like, I'll just step you through it. So we'll usually come to site and we go through every single part of the process, from the minute that it is drilled to when it's designed and estimated and interpreted, to the point where you break the dirt and start moving it around. And at each of those points, what we're really interested in is what information you're capturing, how you're capturing it, and how it's going to get to the next step in the process. When we look at that in a single chain, we can refer to those processes as the value chain. Whether it's the mining value chain or the resource value chain, that's what we're referring to. But between those processes, we refer to that as the data stream. And it's not so much what the processes are, but we're really interested in that space, how we're getting from point to point and from process to process. And I'll admit, I've been working in industry. I was one of the culprits of rebuilding an entire reconciliation program or procedure in Excel. So I apologise for that, for my past sins. I hope that I've, throughout my years, been able to atone for some of those in what we've been doing both at Snowden and at Datamine. But again, the whole point that we're interested in along the data stream is really this concept, which you'd be very familiar with, which is a garbage in, garbage out. And I used to present a 5-day course in resource estimation, and over the 600 slides, there was one slide that had animation, and that was 2 bins, a piece of trash going in one and coming out the other one. That's how important this is that we're talking about. So let's go on to the presentation itself, and let's start by hopefully painting a pretty familiar picture for you on site. Let's talk about what's actually going on. On the right-hand side here, we've got all of our different departments, our different processes or verticals, whatever you want to refer to them. And in between, we have the links. And ideally, we want these links to be seamless. We want them to be very high quality. We want them to be free of errors. But what we usually see in these links are that they're not as tightly linked as we would like. So the different disparate systems which we're usually using to form that communication are things like email. How many people have sent emails to each other with data in them? This is sensitive data or important data. We have file uploads, downloads. These include imports, exports, so manual processes to take information or outputs from a certain process and prepare it so that it can be brought into another one. We've got shared directories. So we realise that maybe email's not a great way to send data. Maybe we decide that, okay, instead of just going on hoof with a flash drive, we need to have a place where we manage these things. So we get on the local intranet and we build a folder that people can upload to and download from. And linking even just these together, we've got so many manual processes. Think about the processes that need to be done. Let's say we need to fire a shot in the pit. Well, to do that, we need sign-off, we need notification, we need to do the ore design of the blocks, we need to have the blast design prepared. That needs to be reviewed by the various parties. And so to do that, we need approvals. We need to tell people things are ready. And usually we end up doing things with pen and paper. Yes, where we're well into the 21st century now, but we're still using pen and paper for a lot of things. We're doing scans, we're bringing them, again, printing them out, taking them over to another site, signing them off with pen and paper, scanning them back in, emailing them back. It's really just adding to the noise. And, you know, throughout the time that I've been consulting, I've seen all sorts of things. Pretty much you can come up with it, it's existed, but don't get me wrong, there are some really out there things, right? But hopefully no one's using those. The other thing I'd like to do before I get into talking about the mining data stream is to reflect on some of these systems. So there's been some research that I found online, and it was a survey of about 1,500 companies worldwide. Within the UK and the United States. And again, this was a survey which asked, what is your primary or preferred method of file transfer within your organisation? And still today, more than half of these companies prefer to use or primarily use emails in order to send data between their departments. So let's just focus on emails then. Well, typically, the general person will spend roughly 11 hours, that's 30% of their weekly workload, just on emails. Searching through emails, reading emails, answering emails, and over 40% of these people have more than 50 unread emails. And somewhere in those emails are the important documents, they're the sign-offs, they're the files which needed to be delivered yesterday. And just as a thought process, I wonder if you can reflect on a time that you've sent someone an email, got a bit upset that you didn't get it back, and decided to walk over there and just talk to them instead. This is not uncommon, and it's happening today. There's obviously another very big one, which is that over 80% of organisations have experienced some kind of data breach related to emails. And a quarter of those were because it was sent to the wrong person. So how can we rely so heavily on a process that is so fraught with risk? And like I mentioned, this is just one of the ones that I mentioned before. Our reliance on these disconnected systems is commonplace, and some of these are buzzwords these days. I think data silos is probably the most common term that I've heard when in a mining environment. I don't know if everyone believes in them, but it's definitely, we all know what we're talking about. But for me as a geologist, by far it's the errors and the inconsistencies which occur due to either poor methods of data capture, poor methods of data transfer, or just the human element that gets added in unnecessarily between each step of the process. And again, this is what we're really looking at when we do things like a reconciliation audit. It is looking at what is the risk that you have according to the processes that you've set up and the data at each point of that process. Every time you rehandle data, you're adding risk, and at the end of the day, what we're doing is trying to make the best decisions that we can for the mining company. I think Craig mentioned that, and this is something that I've always said, what do you think a gold miner is in the business for? It's not mining gold, it's making money. It just so happens that the most efficient way of them to make money is to mine gold. And the decisions that they make are all surrounded about where should we mine, when should we mine, and what should we mine. And the only way that they get a good result in that is to have good input data to make those confident decisions. So let's have a think about the mining data stream. And I've used the word a bit now, so let's step through an extremely simplified theoretical framework for what a mining data stream might look like. And yes, it is quite simple. We have data capture. So for any good data capture, we want to have a few features to it. We want it to be accurate, we want it to be repeatable, and we want to make sure that the processes we have in place can be audited as well. Once we've got this, we then want to be able to feed these into our other areas. Obviously, when we're collecting data, we need a place to store it. So a good data storage has a few features as well. It needs to have someone who is responsible for the data. It needs to have some degree of security. Again, it needs to have auditability. And ideally, it needs to have some method of freely sharing it between the processes in which it's needed. The second part of the framework is the processes themselves that either process that data or analyze the data to give us the results, the information, the insights that we need to actually make those decisions. So I quite like the name of our company, Datamine, because if you've ever talked about data, then you know data mining is the process of actually getting something of value from an enormous amount of muck, of gang, of waste, and that's really what we want to be doing within this process and analysis. We want to be mining the wealth of data that we have for the nuggets of gold that's within it. And the only way that we can do this efficiently without adding in any extra risk or any extra errors into that is to have a method of transferring this data and integrating these different points of processes within our mining value chain along that data stream. So if I was to list out just a few things which I think would be best practice in an integrated data system, it would be standardization of your file types and formats. So all of your disparate systems can speak the same language. We're not having to do conversions or extra processes. So your different steps can all talk to each other using a consistent format. It's an automation of that data retrieval. It's an automation of the synchronization of that data. So getting away from emails, getting away from downloads and uploads. It's those robust security measures. It's so that people like myself can come in and do an audit and we can understand it just as well as the people that are on site. And you protect that data from, I think it was changing the single value in the spreadsheet. I think that's a great example, because if your security is not good enough to prevent that, then we're pointing out exactly the reason that those systems do need to be changed. Backup and recovery, same vein of thought there. Ownership, we have database administrators for a reason. We're quite common that in our industry we have SQL databases which have bulletproof industry standard security around them. We even hire people full-time to be those database administrators. But what about the rest of our data? What about all of our files, all of the downstream? There's only a certain amount that's actually captured in those databases, and yet it's the downstream effects that actually go into all of the daily processes and the decisions that get made. And also, I believe it should be scalable as well. There's very big differences between a junior mining company and a tier 1 mining company. However, we all start somewhere, but the systems that we implement today shouldn't need to get rebuilt from scratch down the track once we pick up some extra resources or tenements, or maybe we're acquired by another company. So I'm a geologist, so I'm going to give you a bit of a talk through of what all of that looks like in maybe a real example, or at least a more real-to-life example. Because I like analogies, I like talking through things which are real and that side of things. So let's consider the data stream as a left to right down the process. And I'm just going to focus on the geology side, some early stage processes. So let's say one of our data sources is the lab. This takes in data from a drilling program. Let's say it's a surface drilling program. We're drilling that ore body that we've got. We're collecting the samples. We're capturing some of the logging and the lithology. We're then bagging it up, tracking the sample numbers, sending it off to the lab, doing our assays, and that material then gets flagged and loaded into our database from that laboratory. We, wherever possible, want as few people and as few paper processes in that stream. For example, when we're drilling at the rig, there's scannable codes, barcodes, to make sure that the right material goes into the right bag in the right order. We can then track that all the way through to the lab, which then should also have a LIMS system, which allows it to link directly back to us, to our database. And typically, this is, again, a pretty familiar place. We would usually use some kind of SQL database. And yes, of course, I'm going to use the Datamine logos for this example. The Fusion's a standard, industry standard SQL database where we can load all of that information back into it. But it's not the only data stream or data source that we're interested in this space. We're also interested in the geology and the interpretation. So traditionally, it would be some sort of geologist would go and take a piece of paper, go down, do the mapping, do the interpretation, bring that back up to surface or back to the office, do a scan, and then we'll go through a pretty awful process of trying to georeference that and so on. Ideally, what we would want to use is some kind of hardware, like the face capture system that Mind Vision has. They're going to get a free shout out at this event. And what this tool does is it takes a quick LiDAR georeferenced image at the face, underground, so that you can immediately get that scanned 3D model. And the best part about this for the geologist is that while underground and while at the face, we can use our tools like Studio Mapper on the tablet itself, removing any of the people transferring data or transferring paper, and we can immediately do that interpretation right there. So what we're trying to do is cut out and automate the process of that data and file transfer. We've also got another tool in this space. So the files which are created by mapping tools don't go into an SQL database typically. There are some things that you can capture which could go into an SQL database, but really a SQL database is all about tables and relationships between those tables. So when we're talking about block models, files, images, wireframes, it's not really suitable for that. But fortunately, we're not the only ones that realise that. And today we have things or databases which we refer to as data lakes. And a data lake is a file-based database. So at Datamine, our file data lake is known as MineTrust. This is a cloud-enabled tool, and without going into any of the deep details, it is that database that we use to manage files. So it has the automatic synchronization from that geological data capture up into MineTrust. And the reason that this is important is that for the next part of our process, we then need to access that data again. We need to get the drill hole data from the SQL database. We need to get the mapping and interpretations from the data lake. And with our tools, we can use these directly without doing import and export, again, to synchronize directly into one of our modeling solutions. So in this case, we're looking at Studio Geo, one of our new ones. And what we're going to do in this space is the interpretation, modeling, and estimation. Now, this goes on, and again, the aim is to go from data capture down through the process, removing the emails, and providing automation around file transfer, file synchronization, and even notifications of these tools. We would then want to synchronize that straight back up, so the outputs, the models, the interpretations, even back into the SQL database for any flagging that we might do on the domains. And then we go down the process into planning and so on. And what we're really doing in this process is we're building out a system. And if we use the dictionary definition, a system is a set of things that work together as parts of a mechanism or interconnecting network. And I really like this term because when we talk about what we're doing with our tools and our software across our entire portfolio, it's really about building that complete mine software system. And for me, it really begins at that data stream and how that's affected by what we're building. And I apologize for hitting you with a big image, but when we talk about how the whole mining value chain sits together and how we wrap these in layers in what we can provide and produce, these are just a few of the areas in which we are building so that we can, as Jono said, be true partners to our mining companies and enable them to implement this mining system. So for this, it seems like a fairly broad and maybe could be a bit staggering to get started, but there's really no need to be overwhelmed. And I don't think this advice will be new to anyone, but really just start small. If you're familiar with the Pareto principle, it's that 80% of your result can come from 20% of your effort. You know, maybe I'm smoothing that out a bit, but effectively what we're saying is that look at your processes and identify where you've got the highest risk with your data transfer, the highest risk of multiple handling, and where you want to save time and improve that process. It's actually coming back to reconciliation, where the reconciliation process isn't about fixing it, it's about showing you where you need to make the change to have the biggest impact. I would definitely recommend looking at those areas and standardizing and automating any workflows you can. Again, if you're still using emails or if you're using shared directories, then perhaps something like a data lake could be a nice way to get the ball rolling. And then gradually scale up. From that area, build on it, extend it, go backwards through the chain, forwards through the chain. Start with these little areas, get them automated, get them running, demonstrate the value, and then grow from there. By doing that, you not only maintain the quality of those implementations, but you slowly and gradually develop and evolve your digitized mine. So, thank you very much, and I'll be open for questions.